This is Statistical and Special Inside YouTube series. Today we are meeting in lesson number 9, which is about testing non-directional hypothesis. By the end of this lesson, you'll be able to explain the difference between directional and non-directional hypothesis. You'll be able to test non-directional hypothesis. Before we get embarked on the explanation of non-directional hypothesis, let us revisit the normal distribution curve that I had previously explained in my YouTube lessons. The normal distribution curve is a curve that covers an area of 100%, or it has a probability of 1. So uh, 68% of the observations under the curve falls within 1 standard deviation. 95% of the observation falls within 2 standard deviation, and 99.7% fall within a standard deviation of 3. Here in this curve, the median and the mode are all equal, and the mean is in the center of the curve. And again, the curve does not approach the x-axis, which means that it does not touch it. Uh, a non-directional hypothesis is a statement that tells or predicts the statistically significant difference or relationship between variables, but it does not specify the direction of that difference or relation. In the directional hypothesis, the direction of the relation is specified by terms such as greater than, smaller than, less than, something like that. Here, such explanation is not possible with the non-directional hypothesis. The non-directional hypothesis is useful in exploratory research where there is no predetermined evidence to suggest specific outcomes. It also allows for the possibility of the difference occurring in either directions, hence the name to tail, that is in either direction of the normal distribution curve. So here let us look at how do we write the alternatives and the null hypothesis. The null hypothesis in non-directional hypothesis suggests that there is no difference, there is no relationship, there is no effect, whereas the alternative hypothesis suggests the existence of difference, the existence of relationship, or the existence of effect. So when you look at the null hypothesis here, the null hypothesis, of course, in this, you'll find that the means of the variables are connected or are related through the equal sign, whereas in the alternative, the means of the variables are actually related through the inequality sign here. That's to say, the mean of variables in the null hypothesis, the means of the one variable 1 is equal to the means of variable 2. In the null hypothesis, in the alternative hypothesis, the mean of variable 1 is not equal to the mean of variable 2. Here, where do we suggest for the location of the critical region? The critical region is very important because it determines when to reject the null hypothesis. It is very clear that if your test statistic probability is extreme to the prefix alpha level, which is 0.025, immediately we are going to reject the null hypothesis if it is less than this. Then, if the total area under the curve is 100%, then it means that on the left tail, the alpha is alpha divided by 2, which is 0.025, and on the other tail, it is also 0.025. When you add these two together, you'll get 0.05, which is 5%, which means that the area for the acceptance of the null hypothesis is still 95% under this situation. So here, I have an hypothetical example of the population mean the weight of the newly born male babies, which is equal to 3.5. Then the null hypothesis is suggesting that the population mean weight of newly born male babies is equal to 3.5 kilograms, which means that wherever you go when you sample newly born babies, then you calculate the mean for the weight, it should approach 3.5 kilograms. Whereas the alternative hypothesis is saying that the population mean weight of newly born male babies is not equal to 3.5 kilograms. So we're going to test this hypothesis here. First of all, we have already set our alpha level because this is a two-tailed hypothesis. Our alpha level is going to be 0.025. So I've taken hypothetical data for the weight of the newly born male babies here. That are about a population of 20. Analysis of such data, because you are analyzing uh, a test value which is known, the population mean, then we are going to use what is known as one sample t test. Never worry about what is here. The most important thing is to understand what is inside these two tables. The first table is telling us about the mean that we have obtained through our analysis, which is 3.49, and the standard deviation is 0.120. And yeah, so this one is the standard error and this one is the standard deviation. So the most important thing here is to look at the two-tailed significance level. The two-tailed significance level is 0.57, which means that it is within the acceptance region. So it is greater than 0.025. So when it is greater than 0.025, so we're going to accept the null hypothesis. The null hypothesis that the weight of the newly born male babies is 3.50 kilogram. In conclusion, uh, reject the null hypothesis if the p-value is less than or equal to your chosen significance, which is 0.025, because it is a two-tailed hypothesis. Fail to reject the null hypothesis means accepting the null hypothesis if the p-value is greater than your significance level of 0.025. This does not prove the null hypothesis is true, only that there is no enough evidence to reject it. So at the end, thank you to attend and participate in this lecture. Please subscribe to my YouTube channel and drop your comments until we meet again in lesson number 10.